Hey there, Schwarberg here. This is lesson 2-3, part B. We're going to talk about some curve sketching and curve catching. Curve sketching can be kind of complicated, so we're going to follow a recipe, a step-by-step process, if you will, for graphing some of these curves, okay? So prior knowledge, what did we talk about? We talked about domain, asymptotes, and holes, right? The discontinuities graphs have. And then we looked at end behavior. So what is this recipe or step-by-step process that I'm referring to? Here in your notes, it says step 1, give the domain. You need to know where you have discontinuities, okay? And in order to find these, sometimes you're going to need to reduce your function if possible, right? Which will give you your holes. Okay, and then from there, right, whatever is left over in the denominator, you can find your asymptotes. We'll find X and Y intercepts. We'll plot those. Those will help us with our sketch and kind of the characteristics of our graph. And optional, check for symmetry. Okay, we'll do that. Oh, I forgot the end behavior. We'll definitely have to analyze our end behavior to say, okay, what's the behavior of our graph in the end, right? Okay, Lincoln Park, if you guys know Lincoln Park. And then if needed, I will do this on the last example. We'll find a starting point that will help us graph it. And then last, graph. Simple enough, okay? So let's go ahead and check this out. Here is our first example of curve sketching. And what we have here is a polynomial. Okay, and a polynomial has domain values that go from negative infinity to positive infinity, right? All real values, all reals. And the reason for this is that we don't have any type of restrictions or values that we have to be aware of. Okay, so what we're going to do, we're going to calculate our X-intercepts next. And remember, for an X-intercept, that we have an X value and our output is 0. So what we're going to do is we'll take our function and we'll set it equal to 0. So X times X minus 1 times X minus 2. These are all equal to zeros. And I can just set them equal to 0 and find the intercepts, right? So I have a X-intercept at 0, 0, an X-intercept at 1, 0. Whoa. Don't know what's happening with my computer. 1, 0. Whoa. Let's see if we can have it a third time. Okay, 1, 0. And then we have another 2 at negative 2, 0. And again, how did I get these? Well, you just take your factor here, right? X plus 2, you set it equal to 0, and you solve. And since this factor is squared, right, we have multiplicity here, times 2. Okay, and we'll talk about what happens visually with those values. Third, we have a y-intercept to calculate, okay? And remember, a y-intercept is when we plug in 0 for for x, and we get a y value. So if I plug in a 0 for all my x values, okay, I get a 0 here, and everything else is going to go to 0. So what I have is 0, 0. Okay, there's my y-intercept, right? Last but not least, we have end behavior. So what happens as x approaches positive infinity? So if we take our function x times x minus 1 times x minus 2 quantity squared, and imagine I plug in infinity here, right? A very, very big number times a very, very big number minus 1, and then also a very, very big number. So all of these, right, are positive infinity. This is just going to go to positive infinity. So at positive infinity, we're going up. All right. Next, we have the limit as x approaches negative infinity. So if I plug in negative infinity in for x, that's going to go to negative infinity. If I plug in negative infinity for x minus 1, that's going to go to negative infinity. So I have a negative times a negative, which is a positive. And then I have negative infinity take away 2, but that quantity is squared. That's going to be positive. So essentially I have a negative times a positive, and that is going to be a positive. So this is positive infinity. So even at this end, right, my function is going up. Okay, so we have our pieces, so let's go ahead and plot these on a graph. And we'll start out with our X-Intercepts. So I have an intercept. Let me switch colors here. Intercept at 0, 0, and intercept at 1, 0, and then multiplicity here at -2. Okay, so I plotted my X-Intercepts. And this also included the Y-intercept, right? That the origin, I have an intercept. Okay, and our end behaviors, if you will, we'll do this third. As I go to the left, my function is going to be going up this way to positive infinity. As I go to the right towards positive infinity, this function is going to be going up. So all we have to do is go ahead and sketch our polynomial. So as I approach this function, as I approach 2, I'm going to touch this and head back the other way, right? That is due to our multiplicity here. Okay, so I'm going to come up, and then I'm going to curve down, and I'm going to go through this intercept and come back up and go through this intercept and go up. And there you have it. Okay, we don't know much information about our max and our min here, but we're gonna have to wait. We're gonna have to get all calculus-y on that, okay, to get those values. So, but that's okay. We just need a rough curve sketch. Next example, 5. So in this case, we have a lot going on, okay, and looking at our graph, notice here, I need to consider my domain restrictions. So x can't be 0, right? Because that'll make my denominator 0. X can't be positive 1. And x cannot be 3. Okay, so those are our restrictions. Now what we want to do is we want to reduce. So I'll look at my numerator and denominator. Here I have an x. This is going to cancel out with one of those x's, and then I have a x minus 1 term is going to cancel out with this x minus 1, so I have x minus 1 in the numerator, and then I have 3x plus 3's. Okay, and my computer's dying, so hopefully I make it through this video. And in the denominator we have x times x minus 3. All right. So what we have now, right, we can analyze our vertical asymptotes. So our vertical asymptotes, I'm going to have one at x equals 0, and this is odd, an odd asymptote. It's kind of odd. And then I have x equals 3. Sorry, I forgot to square it up here. Why didn't you guys tell me? You should have shouted out through the computer. Okay, and this is even. Okay, that means my functions are going to approach at the same side on those. And then we have holes. Okay, so I had a term cancel at x. Okay, x equals 0. And then I had another term cancel for x minus 1. So x equals 1. So I'm going to have holes here. Wow, what a hole. Okay, but here at x equals 0, notice I also have an asymptote. Okay, so this is just going to kind of go away. And I have a hole at 1. Okay, and I want to calculate this. So what's the output when x is 1? And if I plug this in my numerator here, 1 minus 1, that's going to go to 0. Okay, and if I multiply by anything by 0, I get 0, and then the same thing if I divide. Okay, so that 0 kind of takes control there, so my output is 0. There's my hole. Okay, and if you want to find out what the other values are, you can, but just that's the beauty about plugging in something and getting 0. Kind of destroys everything you've worked for, right? All right, next, X-Intercepts. Okay, so I want to go ahead, I want to calculate the X-Intercept for this function. And for me, sometimes I always forget, like, what do I have to make 0? So my function has to be equal to 0. I plug in for y equals 0, and that's how I find my X-intercepts. So 0 is equal to my function, x minus 1, x plus 3 cubed. Okay, and then I have a denominator, but if I multiply by my denominator to get rid of it, right? Okay, it kind of just goes away, right? Because I multiply on the other side, it's going to go away. So I'm left with these terms with just my numerator. And I want to solve for these. Okay, so just like the previous example, I'm going to have an intercept at 1, 0. I'll have multiplicity of -3 comma 0. So there's our intercepts, right? And if I have odd multiplicity, then the function's still just going to pass right through it. Okay. Then we have our y-intercept. So I'm going to plug in 0 for x, and well, am I going to have one? Because I have a vertical asymptote again. Remember here, I have a vertical asymptote of x equals 0. So if I have an asymptote here, let me plot this. We'll graph in green. If I have this asymptote here, okay, am I going to have any y-intercepts? No. So no y-intercepts, none. Okay. And then last but not least, we have end behavior. Okay, so what is the limit as x approaches positive infinity for my function, which is x minus 1 times x plus 3 cubed. Over x times x minus 3 squared. Okay, so remember, for limits, you kind of want to analyze what's the top power, which in this case is going to be x to the 4th, right? I have 3 x's here, and I have an x. This gives me x to the 4th over x squared times x. Okay, this is going to be x cubed. And in this case, we're not going to have a horizontal asymptote. So no horizontal asymptote, right? That's because our numerator is going to kind of dominate this. Okay, so where's our function going? Well, if I plug in positive infinity, okay, I have a positive number times positive number, and the denominator positive, right? I'll just do a little bit of sign analysis. Positive over positive. Okay, so this graph is going up. Okay, it's going to go up to positive infinity. Last but not least, as x goes to negative infinity, okay, I'm going to have a negative times a negative, which makes it a positive. Okay, and then in the denominator, we have a negative times a positive, which is a negative. Okay, so this graph is going to go towards negative infinity. Okay, so I'm just going to say here the limit of our function, and I'm going to get out of this, writing all this, is writing it as g of x. Okay, the limit of g of x is next goes to negative infinity is negative infinity. So let's go ahead and graph this. Okay, so I'm going to graph my vertical and horizontal, or sorry, my vertical asymptotes. Okay, there's my vertical asymptote. And I have a hole at 1, 0. And I have intercepts at 1, 0. Well, I have a hole there, so I lied. Actually, I won't cross it out. I'll just cross that out. Okay, and we have one at -3, 0. Okay, and last but not least, our end behavior. I know my function is coming down this way. Okay, so I'm going to go through this. Now, where's this function going to go? Well, I know that this asymptote is odd. Okay, so I have to pass through this, and I'm going to go up. Okay, and then down here at the other side of the asymptote, it's got to come from the bottom, right? That's what makes it odd. Okay, the function goes different directions. Okay, it's odd, and I'm going to pass through this point. Okay, and I have a hole there. I'm going to go up. Okay, and at the other asymptote, which is even, okay, this graph is going to come from up here, right? And I know that my other end behavior on this end is positive, so I'm going back up this way, right? And no intercept over here. Okay, so that's kind of what this graph looks like. All right, I'm going to pause this video here. I'm going to make a third video, and I'll cover example 6 on that last one.